This is the OCR GCSE 91 Maths Foundation Paper 3 from the November 2020 series, and this paper is a calculator paper. Question number 1. 5 is a factor of 20. We have to write down another factor of 20. Well, let's write down all the factors of 20. 1 times by 20 gives 20. 2 times by 10 gives 20. 4 times by 5 gives 20. We could choose either of these apart from the 5 because it's already been chosen. I'm going to write down 4. Part B, we have to write down a multiple of 20. All this means is numbers that are in the 20 times table. We've got 20, 40, 60, 80, 100, so on and so forth. We could choose either of these. I'm going to choose 60. Question number 2. For part A, we have to complete the first 7 square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And then we've got 6 squared and 7 squared. For part B, we have to write the missing term in each sequence. You will find in this sequence, to go from one term to the next, we subtract 2. And so 14 subtract 2 is 12. So 12 goes here. Here, for the next sequence, we add 6 to get the next terms. Something plus 6 is 14. Well, here we'd have 8. Question number 3. Alex has a number game. He must put down tiles to make 2 calculations with the same answer. Here is what Alex put down. 2 minus 3 times 2 equals 3 minus 5. Is he correct? Show how you decide. Well, what we see here, 2 minus 3 times 2, this result is the same as 2 minus 6, which is minus 4. 3 minus 5 is minus 2. They do not equal each other, so Alex is incorrect, and that's because the minus 4 does not equal the minus 2. Question number 4. A teacher asks 9 of his pupils how many pets they have at home. Here are the results, and what we have to do is work out the range of the 9 results. To work out the range is equal to the largest, 111, minus the smallest, which is 1. The range is 110. For part B, the median of the 9 results is 3. The mean is 5. The mean is 15 rather. We have to write down the mode. The mode is the most common, so let's just write down that definition. The mode refers to the most common, and the most common result here is 3. And now, the teacher wants to use a sensible average to summarize the results. Which average should he use? Well, we know that the median is 3. And all these scores, apart from this one, are close to 3. So which average should he use then? Well, he should use the median because all of the scores apart from the 111 are close to 3. So this is not close to 3. If I was to use the mean, then the mean will be affected by this outlier. Question number 5. For part A, the curved surface of a solid is made from this flat shape. For part A, we have to write down the mathematical name of the solid. Well, we've got a curved surface, and so here we have a cylinder. Next, for part B, this is a plan view of a different solid. We have to write down the mathematical name of this solid. Well, this will be a square-based pyramid. Question number 6. For part A, we have to work out 70% of 50. Well, 70% of 50 is the same as 0.7 multiplied by 50. 0.7 multiplied by 50 is 35. So we have 35. And then, for part B, Beth multiplies a number by 3 and then divides the answer by 10. By what fraction has the number been reduced? Well, if I've got my number n, I multiply this by 3 and then I divide this by 10, which leaves me with 3/10 n. Now, if I've got 3/10 n, that means the number has been reduced by 7/10. And now for part C, we have to find a fraction which is bigger than 3/7 and smaller than 4/7. Well, what we could do over here is have, say, 3.5/7. It's bigger than 3/7 but smaller than 4/7. Now 3.5 divided by 7, that's 1/2. So one fraction which we could have is 1/2. So we write down 1/2. Question number 7. Point A is plotted at 4 minus 2 on this 1 centimeter square grid. That's what we see here. Point A is a corner of a square with area 36 centimeters squared. The other corners of the square have integer coordinates and lie on the grid. We have to find the coordinates of the corner of the square that is diagonally opposite point A. You may use the grid above to help you. Well, if it's diagonally opposite A, it will be in this second quadrant over here. Now we have an area of 36 centimeters squared, which means that from here to here somewhere, we need a length of 6, and we also need 6 going from here to here. So we've got 6 over here. And then what we'd end up forming is a square. And so the point over here has coordinates -2, 4. So the coordinates we have -2, 4. Question number 8. For part A, Joe walks every day. This week she walked at an average of 2,300 steps a day. Next week she plans to increase this by 15%. We have to work out how many steps she plans to walk in total next week. Well, if we take a look at the total steps this week, then we've got 2,300 multiplied by 7, because we've got this many steps per day. So in a week, we'd have to multiply this by 7. So it turns out we get 16,100. And so therefore, next week, she plans to walk a total of 16,100 multiplied by 1.15, because she plans to increase this by 15%. So if I work this out, I get 18,515. So I've got 18,515. And then for part B, Jo buys a pair of walking boots for £63 in a sale. She saves 1/10 of the original price of the boots. We have to work out how much money Jo saves. Well, what we need to do first of all is find out the original price. We begin by letting the original price equal x. So if we save 1/10, that means 9/10 of the original x gives us 63. So if we find out what the original price is, x, 63 divided by 0.9 is 70. So the original price is £70. So how much would she save? She would save 70 subtract 63, which is 7. So we've got £7. Question number 9. Mia has knitted 3 left-hand gloves, 1 blue, 1 green and 1 red. She has knitted 2 right-hand gloves, 1 green and 1 red. She chooses a left-hand glove and a right-hand glove at random to make a pair of gloves. Mia says, I have a probability of 2/3 of choosing a pair of gloves of the same colour, as there is a red pair and a green pair and there are 3 colours. Is she correct? Show how you decide. Well, let's write out all the combinations. We could have 1 blue and 1 green. We could have a blue or a red. We could have a green and a green. Or we could have a green and a red. We could have a red and a green. Or we can have a red and a red. So what we can see then is the probability that we've got the same colour out of 6. 2 of them are the same colour. This is the same as 1/3. So therefore the probability is equal to 1/3. So Mia is incorrect. And that's because the 1/3 does not equal the 2/3 which she got. Question number 10. Sundip is going on holiday. She wants to change £400 into euros. Bank A will change her £400 into 452 euros. Bank B changed £250 into 280 euros for Sundip's friend. It will use the same rate to change Sundip's £400 into euros. At which bank will Sundip receive the most euros, and by how many? You must show your working. Well, if I take a look at Bank B, what we know so far about Bank B, we've got £250, which is changed into 280 euros. Now, let's see what the equivalent £400 is. Now, for us to find out what £400 is, what we can do is find out what £50 is worth, and then we can find out what £400 is worth. So, from the 250 to the 50 we divide by 50, so I also need to divide this by 50. And if I work that out, 280 divided by 50, rather 280 divided by 5, is 56. So £50 is worth 56. And then if I multiply by 8 and times by 8 over here, I get 448. And so therefore, £400 is equivalent to £448 with Bank B. And therefore, you can see Bank A gets us the most money. And if we find out the difference, 452 minus 448, that's equal to 4. So the difference is €4. Question number 11. 5 lots of 2x plus 1 plus c lots of x plus d is equal to 2x minus 1. We have to work out the value of c and the value of d. Well, let's expand the brackets. 5 times by 2x is 10x. 5 times by 1 is 5. C times by x is cx. C times by d is cd. This is equal to 12x minus 1. So in terms of the x's, we've got 10 plus c of them. And in terms of the numbers, we've got 5 plus cd of them. And this is the same as 12x minus 1. So if I take a look at the x's, you can see I've got 10 plus c equaling 12, in which case c is equal to 2. And if I take a look at the numbers, I've got 5 plus cd on the left and minus 1 on the right. So I've got 5 plus cd equals minus 1. I know what c is, that's 2. So I've got 5 plus 2d equals minus 1. 2d is equal to minus 6. D is equal to minus 3. And so we get c equals 2, d equals minus 3. Question number 12. For part A, we have to complete the power of 2 for each statement by writing the missing value in the box. I've got 2 to the power of 3 times 2 to the power of 3. Well, here I need to add the powers. So this is the same as, well, let's just write this down. 2 to the power of 3 times 2 to the power of 3 is the same as 2 to the power of 3 plus 3. So I have 2 to the power of 6. Next, I've got 1 over 32 equals 2 to the power of something. Well, 1 over 32 is equal to 1 over 2 to the power of 5. And if I work this out, I can rewrite this as an indice. I've got 2 to the power of minus 5. So 1 over 32 is the same as 2 to the power of minus 5. And then we've got 2 times by 2 to the power of y equals 1. We have to find the value of y. Well, I've got 2 to the power of 1 multiplied by 2 to the power of y, which is the same as 2 to the power of y plus 1. Now this over here is equal to 1. And 1 is the same as 2 to the power of 0. So I've got 2 to the power of y plus 1 equals 2 to the power of 0, which is 1. So the result here is what 1 is equal to. So I've got y plus 1 equals 0. Y is equal to negative 1. Question number 13. A mass of flour used in a recipe doubles as the number of biscuits is made doubles. On the axis below, we have to sketch a graph to show this relationship. Well, as the number of biscuits grows, the mass also doubles. So here what we need is a positive gradient passing through the origin. As this increases, this also doubles. So here is our line. And then for part B, here are some of the ingredients for a recipe to make 10 biscuits. We need 120 grams of butter and 100 grams of sugar. Jane followed the recipe and used 432 grams of butter. All of the sugar used came from a new 2 kilogram bag. We have to find the number of biscuits she made. What we are essentially saying over here is for 10 biscuits, we need 120 grams of butter. Now what's happened is we've used 432 grams of butter, and with this we need to find out how many biscuits we made. So how do we go from here to here? Well, 432 divided by 120 is 18 over 5. So here we times 120 by 3.6 to get the 432. And so we'd have to multiply 10 by this to get 36. So 36 biscuits are made with 432 grams of butter. And then for the next part, we have to find the mass of the sugar in grams that Jane has left in the bag. Well, for 10 biscuits, we know the amount of sugar is 100 grams. Now, we've just said we've made 36 biscuits. So how much sugar do we use here? Well, how do I go from the 10 to the 36? What do I multiply 10 by to get 36? Well, that's just 3.6. So I need to multiply 100 by 3.6 to get 3,600 grams of sugar. Now, all of the sugar she used, well, let's just double check this. 3.6 multiplied by 3 multiplied by 100 is 360 rather. So she used 360 grams of sugar. And then what we have to do is, well, we've used 2 kilograms. 2 kilograms is the same as 2,000 grams. So the sugar she's using comes from this bag, and therefore the sugar that we've got left in the bag, we can calculate. This is equal to 2,000 minus 360, which is 1,640. So this is the amount of sugar we've got left. Question number 14. A travel agent records the duration and cost of the 15 flights he sold on Monday. The data for the first 13 flights are plotted on this scatter diagram. The data for the final 2 flights is 210 minutes, the cost is £130, and 1 hour 40 minutes, cost is £80. We have to plot these on a scatter diagram. Well, first of all, 210 and 130. 210 is here, and then going up to 130. 130 is in between these. So it's plotted over there. And then 1 hour 40 minutes. Well, what is 1 hour 40 minutes? We've got 60 minutes plus 40 minutes, which is 200 minutes. So 280 we now need to plot. So 280 goes over here. So we've plotted those points, and now for the next part, the cost of one of the 15 flights had been discounted in a sale. We have to circle the most likely on the scatter diagram. Well, we want the one with the lowest cost, and the lowest cost is the one over here. So we circle the point here, which is 220.64. Next, we have to draw a line of best fit. So if I go back to my diagram, if I draw a line of best fit, we want it to go through as many points as possible. We want roughly the same amounts above the line as we have below the line, as we see here. Here is our line of best fit. And then we have to use the line of best fit to estimate the duration of a flight costing £90. So £90, draw a line up from here and then a line across. So that's going to be 90. Rather, we want a line of best fit costing, we want the duration cost when the cost is 90. So if I go back, 90 is over here. Draw a line across and then a line down. The duration is 110. So we have here 110. And for the next part, we have to explain why the travel agent should not use his records to estimate the cost of a 7-hour flight. Well, 7 hours, that's clearly outside the data set. So what we'd write over here is 7 hours, which is equivalent to 420 minutes, is outside the data set. Question number 15. A rectangle is 3 times as long as it is wide. It's got a perimeter of 44 centimeters. We have to find the length. So what we'll do over here is, if I've got a rectangle over here, suppose that it's x centimeters wide, then the length of it will be 3x, 3 times as long as it is wide. So I've got x plus 3x plus x plus 3x, which is equal to 44. So I've got 8x, which is equal to 44. And so therefore, if I find out what x is, I get 5.5. And therefore, the length is 3x, so that's 3 lots of 5.5, which is 16.5. Question number 16. We have to solve 3x plus 4 being less than 19. So if I've got 3x plus 4 being less than 19, subtract 4, so we are left with 3x being less than 15, and if I divide both sides by 3, then x is less than 15 over 3, which is 5. So x is less than 5. So I draw a circle over here which is empty, and that's because of the inequality symbol shown. I want values of x less than 5, so I draw a line to the left, everything going this way. Here is the inequality shown on a number line. Question number 17. The area of the triangle is equal to the area of the trapezium, and we have to calculate the height of the trapezium. First of all, let's calculate the area of the triangle. The area of the triangle is equal to 8 times by 9 divided by 2. So if I work this out, we get 36 centimeters squared. So therefore, the area of the trapezium is equal to 36. And knowing that, how do I calculate the area of a trapezium? Well, that's 1/2 lots of the sum of the two parallel sides, 12 plus 20, lots of h. This is equal to 36. So what I can do now is find out somehow what h is. So 12 plus 20 times 1/2 is 16. So I've got 16h equals 36, and if I find out what h is, 36 divided by 16 is 2.25. So therefore, h is equal to 2.25. Question number 18. Here is a right-angled triangle. That's what we see here, and we have to use trigonometry to work out the value of x. Well, if I work out the value of x, I've got the opposite, the adjacent, and an angle, so I have to use tan. Tan 34 is equal to x over 8. So therefore, x is equal to 8 times by the tangent of 34. So if I work out what this is, 8 times by the tangent of 34 is 5.396, etc. So that's what x is. Question number 19. For part A, we have to work out the size of the exterior angle of a regular 12-sided polygon. Well, the exterior angle is equal to 360 divided by the number of sides. We've got n. So we've got 360 divided by 12. And if I work out 360 divided by 12, I get 30. So the exterior angle is 30 degrees. And now the interior angle for part B, this is equal to 180 minus the exterior angle. So I've got 180 minus the 30, which is 150. So the interior angle is 150 degrees. Question number 20. A truck is used to transport some wood panels. Each wood panel is a cuboid measuring 2.4 meters by 1.2 meters by 1.8 centimeters. The density of each wood panel is 750 kilograms per meters cubed. A truck can carry 15 tons of these wood panels. We have to calculate the maximum number of wood panels that the truck can carry. Show how you decide. Well, we've been given information about the dimensions of a cuboid. We've got the density. With this, we can find out the mass. So first of all, we need to work out the volume. Before we work out the volume, we need to convert the centimeters to meters. And to do this, I need to divide by 100 to go from centimeters to meters, and meters to centimeters times by 100. I'm going to convert into meters to keep the units consistent. So if I divide 1.8 by 100, I get 0.018 meters. So with that, I can find the volume. That's equal to 2.4 meters multiplied by 1.2 meters multiplied by 0.018 meters. So if I work this out, I get 0.05184 meters cubed. So the density, well, we know what the density is. That's 750 kilograms per meters cubed. So therefore the mass of these planks of wood, we've got 750 kilograms per meters cubed multiplied by 0.05184 meters cubed. So if I work out the mass, I get 38.88 kilograms. Now, I've been given information. I've got tons and I've got kilograms. So I know that in 1 ton, that's equal to 1000 kilograms. So what I need to do is convert the 15 tons into kilograms. That's equal to 15,000 kilograms. And so therefore the maximum number of wood panels that the truck can carry, we've got 15,000 divided by 38.88. So if I do 15,000 divided by that, I get 385.80, etc. So the maximum number we can carry is 385. So we round down. Question number 21. Vectors A and 4B are drawn on this grid, and we have to write A as a column vector. Well, if we take a look at A, we go 2 down, and then we go 4 to the right. So we've got -2, 4. We now have to find B as a column vector. Well, let's first of all find out what 4B is. You can see we go 4 to the right, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So what you can see here is (4b) is equal to the vector 4, 9, and therefore 1b is equal to 1/4 of 4, 9, which is 1 and 9 over 4. Question number 22. For part A, we have to complete this table for y equals x squared minus x. Well, when x is equal to minus 1, I've got minus 1 squared minus minus 1, which is 2. And then when x is 1, I've got 1 squared minus 1, which is 0. For part B, the graph of y equals x plus 1 is drawn on the grid. On the same grid, we have to draw the graph of y equals x squared minus x between minus 2 and 3. So we need to plot these points and draw a smooth curve. Here is the plotted graph. It's just a rough sketch. And now for the next part of the question, we have to write the x coordinates of the points where x squared minus x and y equals x plus 1 cross. Well, they cross at two distinct points. One of the points is over here at minus 0.4, and the other point where they cross is over here at, let's just sketch this properly. The other point where they cross is at 2.6. So the coordinates where they cross, we've got 0.4 and 2.6. Question number 23. The probability that Adam cycles to school or walks to school depends on the weather. On any day, the probability that the weather is wet is 0.4. When the weather is wet, the probability that he cycles to school is 0.3. When the weather is dry, the probability that he cycles to school is 0.8. The information is shown on this tree diagram. For part A, we have to work out the probability that it's dry and Adam walks to school. So what we are looking for is the probability that it's dry and we walk to school. So if I work out what that is, the probability that it's dry and we walk, that's equal to 0.6 multiplied by 0.2, which is 0.12. And then, for the next part, the probability that Adam cycles to school. Well, for him to cycle, he could either wet and then cycle, okay, or it could be dry and then he could cycle. So we've got 0.4 plus 0.3, rather 0.4 times 0.3, or we've got 0.6 times 0.8. And if I work this out, I get 0.6. So the probability is 0.6.